Okay, there is one more presentation to go. It's from Alexander Sadowski from Alzado. And we talk about fully open source workflow for FEM crash simulation in automotive and aerospace. Alexander Sadowski is the owner of Alzado, where he offers FreeCAD support and teaches manufacturers through training how to use FreeCAD, integrates it into existing processes, and further develops FreeCAD through add-ons to optimize design and manufacturing processes. Alexander is the author of the book FreeCAD Beginner's Starter Kit. Before founding his company, Alexander developed simulation and real-time software for German military, BBK, and NATO. He also worked at Grob. I think there's a machine builder.
It's a
machine builder, okay. Yeah. Machine safety and is the inventory of the safety screw. Alexander studied mechanical engineering at Hochschule Bonn-Rhein-Sieg. So we look forward to your presentation.
Yeah, thank you very much for the nice introduction. Welcome everyone. Today I will show you how you can do crash simulations in automotive and in aerospace just using open source software. So this is actually something new. Up until recently, doing those crash simulations using only open source software was either very tedious or pretty much impossible. And since Altair has open source open radios, this opened up another possibility for us to now realize this whole process in open source software, but there was just one missing link. And the missing link was between our open source preprocessor PrePomax and the open source solver Open Radios, which was a conversion from the Calculix input format to the radios format. And so I contacted Eric from Altair and said, hey, Eric, let's do this. Let's make this happen. Let's develop this whole workflow. So, and Eric was, yeah, let's do it. I'm happy to help you with that. And then Paul from Altair developed this converter, and yeah, it's all history from there. For the first time, it's actually possible to do easy to use crash simulations using only open source software, beginning with CAD modeling up until the result presentation or visualization. So, to showcase this entire workflow, we have picked a very specific use case, which is the crash simulation based on a simplified version of the Euro NCAP full width crash tests. And we have built up this entire model in FreeCAD. This model is used to validate this whole process. Obviously, we will not develop an entirely new car for just this use case, but I think this is good enough just to show how it works. Here is a quick overview over the workflow. So we start out with FreeCAD, where we do all the CAD geometry generation. Then we move on to PrePomax, where we do all the pre-processing, including meshing, boundary conditions, time, and so on. We then move on to Open Radios, where we solve the whole case study. And then all the results from Open Radios are visualized in ParaView. So here's an overview over the EV platform that we chose. This EV platform is made up of different parts. We have got a front crash structure, which is the deformable shell. We have wheels, which are rigid solids. We have got a frame, which is a rigid shell. We've got a battery, which is also a rigid solid. And we've got a rear crash structure, which is a rigid shell. For this case study, we are just looking at the front crash structure and see what deformation it has. All the other parts are constrained so that they are rigid. We've specifically picked the wheels to be solid bodies just to show that we can mix shells and solids in this workflow. So first, for the geometry creation, we have got FreeCAD. FreeCAD pretty much works just like CATIA. For anyone who is familiar with CATIA will know that. FreeCAD is built up of different workbenches. Some of them are even called the same way that they are in CATIA. And in FreeCAD, we can create shells, solids, create assemblies, and after we have created our geometry, we can then export it as a step file. How we create shells, this is for most of you probably not that interesting, but we use part workbench and sketcher workbench, and for solids we use the part design and the sketcher workbench. And the overall workflow is very similar to CATIA, so for users that already use CATIA, it's very easy to transition to FreeCAD. Then, once we have exported our whole assembly, including the whole EV platform and also the wall that we have constructed in FreeCAD, we can then load it as a step file into our preprocessor, which is called PrepoMax. PrepoMax just works like Abacus. This is probably not a coincidence. And inside of PrepoMax, we import our geometry. We create compounds to reduce the number of constraints. We set the mesh type, mesh the parts, like all the steps that we usually have to do to pre-process our model. There are some exceptions which we will have to look at. So you cannot right now specify fracture inside of PrepoMax as a material. Also, the materials are not very complex that you can use in PrepoMax. You cannot do any stress strain curve, and plastic deformation is just supported. It's not the most complex. So, in order to implement some more advanced features, we have to go into the keyword editor, where we can directly edit the Calculix input file, which PrepoMax uses. PrepoMax is basically just a graphical user interface for Calculix. And in there, what is very important, in order to use general contact in our case study, we set, for example, the keyword radius general and underscore general. We don't have to go into that much detail right now, but there are specific things that you can set in PrepoMax to set flags, basically, where in the next step, where we load the Calculix input file from PrepoMax into OpenRadius, so that OpenRadius recognizes all of them. And here are just some of them. For the materials, we use placeholders, which we can then replace with radius materials. For selecting our sections, we should not use the graphical user interface, but rather the drop-down. We define the general contact with radius general. We need to, whenever we are using reference nodes, we need to go into this Calculix editor and add a velocity to them when we are using those for our assembly. And there are, like you can see, there are some tweaks that have to be done on top of the usual case setup inside of PrepoMax. But after we have done that, we can then import this Calculix input file into the OpenRadius graphical user interface, which already right of now, it really makes it much more easier to work with OpenRadius than before. And what this graphical user interface will do, it will translate the Calculix input file into a radius input deck. This is what I was talking about previously. This is the extra step that has been added right now, which enables even this whole process to even work. So, when we have done that, here is the step. Once the conversion is performed this is the step where we have to define our radius materials with plastic material behavior, fracture, stress strain curve, and stuff like that. And what this open radius, what it outputs radius animation files. These radius animation files are later on also automatically transformed into VTK animation files, which can be read by ParaView. And since ParaView is also open source, we can use that. So there is also an executable available of the Open Radius GUI, which you can just download and use it right away. And it bundles all the necessary stuff that you need to run Open Radius. So once we have got our animation files as VTK files, we import them into ParaView. And inside of ParaView, we can also import all the other data, for example, the data on the reaction forces, acceleration, and other data that we need for our crash simulation. And this can also all be displayed inside of ParaView. Inside of ParaView, this is mostly important for marketing. You can also create an animation, export it, and then use it for, for your social media or anything else. We do that quite a lot. Yeah. So here it is. This is the case. This is not a video. It's just a screenshot of this video because I didn't want to include a video in case it won't work. But as you can see, we have crashed the EV platform that we have specifically built to showcase this entire workflow. The front crash structure is deformable with plastic material behavior and fracture, and all the other parts are rigid, including the wall. So, as you can see, it is possible to create an entire crash simulation just using open source software. Why is this important? This is important because it enables small companies to go into this field. So you don't need hundreds of thousands of euros to spend on licensing, and then it doesn't turn out. So here, as far as the financial side, you have pretty much zero risk. And this entire workflow has been validated throughout this project. We have also created a different case study where we simulated a drop-off maneuver of a Mars rover. This is something that you can imagine. You have your rocket which gets shot up to the Mars, and then you have your this I don't know the name, this thing which then shoots out the Mars rover. And what we analyzed here is what impact it has on the suspension. The Mars rover is, it's kept very simple on purpose because we will be doing some high-speed video tests where we will compare this model getting drop off of like 1 meter on Earth and filming that with a high-speed camera, and we will compare the results from that with the simulation results that we get here. So this would even further validate this whole process. Here's again an overview over the entire process. So at the beginning, you have got FreeCAD for your CAD geometry generation. We export all our geometry as a step file and import that into PrepoMax. From PrepoMax, we export a Calculix input file and load it up into the imp.to-rad converter, which converts it into those two rad files. In those two rad files, we then define our material behavior which is plastic and fracture. We then load those up into the starter and engine of OpenRadius, which is the core of OpenRadius. OpenRadius then performs our simulation and outputs, for example, our animation files. These first radius animation files are then converted to VTK, and from VTK we load those VTK files in ParaView. So as you can see, we can realize this whole process just using open source software. What are the other benefits of open source software? Open source software has very good documentation usually and good support from the communities. So for each of these softwares, there are forums or any other places on the internet where you can ask people if you don't know how to do something. All of these softwares are available right now. You can go home and download all of them and do the simulation on your own. Here are the specific versions we used. For PrepoMax, it's very important that you use version 2.1.0 because there is a bug in the version after that, and you should use this version. For all the other versions, it's not that important because they just work. So, thank you very much. This has been our talk on this open source workflow. There is still one thing. What we have been working on recently is because we don't like all these steps, like all the green stuff, it's just too many steps. The green, the yellow, and so on. So we actually started to develop a new post-processor which already includes OpenRadios, and it runs on the web, it runs locally, it has out-of-the-box MPI support, which enables multiprocessing. You don't have to set up anything, you just double-click on it, and it works. So this is something that we are working on right now. We have already announced this just when there was the acquisition of Altair by Siemens, and very soon we will show more about this project. I thank you very much for listening, and if you have any questions, go ahead.
So, thank you very much for this nice presentation, and we are looking for questions. Okay, please.
Hello, Utkarsh Pule, Master's Graduate at FH University. Thank you for your presentation. It was really nice to finally know your workflow with all the open source software. Unfortunately, I missed the last week's event. My question lies in slide number 7 for reference. So you showed the complete, workflow for pre-processing, setting up the mesh. More importantly, my interest lies in, for example, defining node or surface groups, because I worked with HyperWorks, and there are a lot of ways you can define node groups or surface groups, and then more importantly, you talked about defining contacts between individual parts. So if you define, you can define a node-to-node contact or node-to-surface contact, but not surface-to-surface contact for OpenRadios or radios, as far as I know. So it's all in the future work. My question is how flexible such things are, such as defining node groups or basic surface groups.
So just to reiterate your question, so you are asking if it's possible to create node groups, surface groups, and stuff like that inside of PrepoMax?
Yes, and how flexible it is. So how can you customize also as an additional question?
So usually when you define your boundary conditions and stuff like that, it creates those groups automatically when you select them in the graphical user interface, or you can explicitly group several surfaces or nodes together. And as you can see here, there are these groups, so there is node sets, element sets, surfaces, so you can define those beforehand.
Okay.
If all of this works in Open Radios, we still don't know. This is really fresh. This is like new stuff.
Yes, completely understand it. Thank you very much.
Thank you very much.
So thank you very much again. So we have finished now.
Yeah.
Thank you again for your presentation and for the present.